In this lesson, we want to learn about inverse cosine function. Cosine function is not a one-to-one function, but if we limit ourselves to the region where the cosine function is one-to-one nearby y-axis, then we can define an inverse function. The cosine function is one-to-one between 0 and pi. If we think about the quadrant, then from 0 to pi over 2, that is quadrant 1, and pi over 2 to pi is quadrant 2. So inverse cosine function is defined in the quadrant 1 and quadrant 2 between 0 and pi. If we think about the angle location, the angles will be located in quadrant 1 and quadrant 2. In quadrant 1, cosine is positive. In quadrant 2, cosine is negative. As I said, we define an inverse function of a cosine function on 0 to pi. We follow the general convention to denote the inverse cosine function. We denote the inverse cosine function as y equals function name cosine, and then we attach -1 right here, and x is an input. What's important is that it's not cosine of x to the -1 power. This one is 1 over cosine of x. That is not an inverse function. Sometimes we use arc cosine notation, ARC, COS, and we read arc cosine of x. That is the same as inverse cosine of x. Inverse function is obtained by switching x and y in the original function. So y equals cosine inverse of x means cosine of y equals x. So when we think about cosine inverse, that is x is a cosine function value, and y is an angle between 0 and pi. Here y is the angle and x is a cosine value. Range of cosine inverse function is from 0 to pi. In the original function, 0 to pi belongs to the domain, but in the inverse function, domain and range will be switched. So 0 to pi will become a range of inverse cosine. And domain of y equals cosine inverse of x is from -1 to 1. So range of cosine was from -1 to 1, and then in the inverse function that became a domain of the inverse function. Let's graph inverse cosine function. Previously, we limited ourselves from 0 to pi and doge were x value. This time, that doge become y value. This is pi over 2, and this is pi. And the range was from -1 to 1, so the domain became -1 to 1. Let's pick some sample points to evaluate. Cosine of 0 was originally 1. If we switch the output and input, then it becomes cosine inverse of 1 equals 0. So output became an input of the inverse function, and input became an output of the inverse function. Cosine of pi over 2 equals 0. We do the same thing. Cosine inverse of output became 0. Output became input value, and then the inverse value becomes pi over 2, which was the input. Cosine of pi equals 1. Then cosine of pi is -1. So cosine inverse of -1 equals pi. Again, output became input and input became output. Let's mark according to what we got. Cosine inverse of 1 equals 0. So this point, and cosine inverse of 0 is y value pi over 2. Cosine inverse of -1 is pi. So we have to graph inverse cosine based on this graph. What you have to keep in mind is x and y axes are switched. So angles are listed here. When we switch it, x and y, and the wave will be limited between these two vertical lines. So If you imagine the cosine function, then that is a wave function which starts at the maximum value and pass through 0 and then go down. If you think about the extended version, then cosine function looked like this. But we are thinking about the inverse cosine, so we limit ourselves from -1 to 1 and 0 to pi instead of keep drawing like that. Let's do some examples. Cosine, inverse of 0. We already did it, but let's just follow the definition of the inverse cosine. Cosine inverse of 0 is the angle theta, which is located in 0 to pi. If we reinterpret that, then we switch it x and y. That means cosine of that angle becomes 0. So what we will think about will be the cosine function. This is y equals cosine of x. We know we limited ourselves from 0 to pi, where cosine is 1 to 1. This point where the cosine value is 0 was pi over 2. So we can say that theta equals pi over 2. That implies cosine inverse of pi over 2 equals 0. Cosine inverse of 0. Cosine inverse of 0 equals pi over 2. Second example is cosine inverse of 1 over 2. We again follow the straightforward definition. We are looking for the angle whose cosine function value is 1/2, but the angle must be located between 0 and pi. When we consider the quadrant, it should be located either in the first quadrant or second quadrant. If we rewrite this one with cosine, then cosine of theta equals 1 over 2. Apparently, the value is greater than 0. In the first quadrant, cosine value is greater than 0 because cosine of cosine is determined by the sine of x. All x values in the quadrant 1 is positive. So in the first quadrant, cosine is positive, and we can say theta is in the first quadrant. Then we try to identify that with the special triangle. It has 1 and 2, so apparently the triangle we have to think about will be 30, 60, 90 degree triangle. So 1, 2, square root of 3. 1 is adjacent, and so this is adjacent. Adjacent to this angle is pi over 3. And 2 is hypotenuse. So pi over 3 can be the reference angle of the angle theta, but cosine is positive, so the angle is located in the first quadrant. So reference angle itself become the desired angle. Cosine of pi over 3 equals 1 over 2, and theta equals pi over 3, because that is already in 0 and pi, between 0 and pi. The next example is cosine inverse of minus 2. Let's say cosine inverse of minus 2 equals theta, which is an angle between 0 and pi. So that means cosine of theta equals minus 2. But if you look at the number, then you will realize that that is impossible, because the cosine function is bounded by minus 1 and 1, and minus 2 is less than minus 1. That is impossible. Therefore, cosine inverse of minus 2 is undefined. If you think about the graph of the cosine, then what's going on here? This is 1 and this is minus 1. The entire cosine function stays between minus 1 and 1. But if you think about minus 2 and draw the horizontal line, then that horizontal line never meet with the cosine function. So there is no inverse image. That means cosine inverse of minus 2 is undefined. Next couple of questions will be about using calculator. Use a calculator. In radian mode, to find an approximate value of the expression. Correct to 5 decimal places if it is defined. Cosine inverse of minus 2 over 7. Make sure that that is in the radian mode. Otherwise, you have to use the RG button to change the mode. So radian mode. And then we will evaluate this number first. So 2 divided by 7, and then evaluate that number. And then we switch the sign by using plus or minus button right here. And then cosine inverse second and cosine, because that is written as green character. Let's do that. That's approximately 1.86055, because right after 4, that is 8, which is greater than 5. Second question is cosine inverse of 2 over 9. Again, make sure that that is in the radian mode. It's simpler than the previous one. 2 divided by 9, and then evaluate, and then cosine inverse second and cosine. Let's do that. 2 divided by 9, and then second cosine. That's approximately 1.3467. After 0, that is 3, so that is less than 5, so we don't round up. Let's discuss the inverse function property of cosine inverse. Cosine inverse of cosine of x equals x if, only if x is between 0 and pi. That also means if x doesn't belong to the angle ranges between 0 and pi, then we have to figure out the angle whose cosine value is the same, but the angle belongs to 0 and pi. Let me write x, if x doesn't belong to 0 and pi, then cosine inverse of cosine of x is an angle between 0 and pi with the same reference angle and the same sine. So here, reference angle is important, and considering the sine of cosine is important. Let's do some example. Find the exact value of the expression if it is defined. The first question is cosine inverse of cosine of 5 pi over 6. Let's put cosine inverse of cosine 5 pi over 6 as theta. The angle between 0 and pi. Then we can reinterpret that as cosine of theta equals cosine of 5 pi over 6. The angle involved on the right side is 5 pi over 6. If that angle belongs to 0 to pi, then that angle will be the answer. So 5 pi over 6 belongs to 0 and pi because pi is 6 pi over 6. Or you can just locate the angle here. And the range of cosine inverse is either the angle in the first or second quadrant. So theta is 5 pi over 6. Cosine inverse of cosine of 11 pi over 6. That is cosine inverse of cosine of 11 pi over 6 equals, again, the angle theta in the interval 0 to pi. Cosine of theta equals cosine of 11 pi over 6 because this is an input. So input and outputs are switched. So in cosine, theta is an input and cosine of 11 pi over 6 is an output. Let's locate the angle. This is 0, this is pi. This is the range of cosine. And this is 2 pi. That is 12 pi over 6. 11 pi over 6 is a little less than 12 pi over 6. So apparently angle is in the fourth quadrant. This is 11 pi over 6. Previously, what we said was that if x doesn't belong to the interval from 0 to pi, then what we have to consider will be reference angle and the sine of cosine. Let's calculate the reference angle. Reference angle can be calculated by comparing this angle and this angle, the closest x-axis and this angle. the differences between 11 pi and 12 pi is pi, so the reference angle is pi over 6. And then we have to consider the sign of cosine. In the first quadrant, sign of cosine is positive, and in the fourth quadrant, cosine is also positive. So what we can say is cosine of 11 pi over 6, when we express that with the value with the reference angle, that is plus or minus cosine of reference angle of this one, 11 pi over 6, which is pi over 6. But in fourth quadrant, that cosine is positive, so we don't put minus here. So we found the angle between 0 and pi. Therefore, the theta, the final answer, theta, which was cosine inverse of cosine of 11 pi over 6, equals pi over 6. There is another inverse function property. Cosine of cosine inverse of x equals x only if x is between -1 and 1. This time the input is cosine inverse of x, which is the angle between 0 and pi, and so cosine of this input is x, means that is the cosine value. So this x must be in the range of cosine, which is from -1 to 1. If x doesn't belong to -1 to 1, then cosine of cosine inverse of x is undefined. Because the x value is not in the range of cosine value, so that is not defined. Find the exact value of the expression of cosine inverse of -2/9 if it is defined. We will handle this part first. Cosine inverse of -2/9 is the angle between 0 and pi. That means cosine of theta is -2/9. This is a cosine value. Apparently, that value is the number between 1, negative 1, and 1. Let's rewrite what is given. Cosine of cosine inverse of minus 2 over 9. Then we can rewrite that as cosine of theta. What we do is just the substitution. Cosine inverse of minus 2 over 9 was theta. So instead of cosine inverse of minus 2 over 9, we are writing theta because of this. And in the second line, cosine of theta was minus 2 over 9. That is a valid answer. So the final answer is minus 2 over 9.